Okay, to get more spaces. Okay, this is for our review. Okay, remember when we learn imaginary and real part. Okay, now we try to solve for this one. We try to solve for this function or the transfer function. Okay, first of all, we need to separate into small function. Okay, before that, make sure the lowest order will become 1. Okay, that's for example 5. Okay, term 5 should be divided by 5 and then multiply 5, so that is equal to 1. Okay, 100 s plus 1. Okay, how to make 5 there? So it's 5 here divided by 5 there. S divided by 5, so it becomes s. My s is equal to 5 plus 1. Okay, and then the other quadratic function will be s, okay, square root 12. Okay, need to be in this form. Okay, plus, okay, we have 7 divided by 12. Okay, square root 12 squared, it become 12. And then plus 1. Okay, so you divide 12 times 12 here. Okay. So after that we simplify it. Hundred divided by 60. 100 divided by 60. We have s plus 1. Okay, now we already make the each function in the proper term. Okay, so we have to separate it. G1 equals to 10 over 6, and then G2 1 over S. Okay, our S will become 0.2 because divided by 5. J omega. Okay. S we want to replace with J omega plus 1 later. G1, G2, G3. Okay. G1, G2, G3. Okay. So this one without replacing S. S. So now we replace S equals to J omega. And we name it as step 1. Step 1. And then step 2. We have the magnitude and also the phase angle. Okay, the phase angle. So our magnitude G1 J omega equal to 10 over 6. Okay, you can refer to this one. Why it's become 10 and 6? Because it become 1. Okay, when you square root the same thing and make it the square and square root it. So it's become the same value for G1. Okay, how about angle of G1? Equal to arctangent of 0 divided by this value. So you have 0. Okay. For G2. Okay, for G2, 0.2 J omega plus 1. We write, this is phase. This is phase G1. Okay, because you want to calculate for magnitude G2. Okay, so we have the other magnitude G1 equals to 10 over 6. Okay, for magnitude G2, 1 divided by, okay, J squared become negative 1 and then square it, so it become 1. So you have 0.2 omega squared plus 1. Okay, plus 1. Okay, then we have G2 phase. Okay, G2 phase. Okay, arctangent of 0, so it's 0. 0 divided by 1, so it's 0. Minus arctangent 0.2 omega divided by 1. So what you have here is minus arctangent 0.2 omega. Okay, that one for G2. Okay, we write for G3. G3. G3 is square root of okay, if you replace, we replace it first. So it's J omega. Okay, replace S equals to J omega first. Okay, like that. And then this is not the magnitude yet. And then we know the imaginary and real part. Imaginary and real part. So we have here negative 1 squared. So it's equal to 1. And then omega will become the real part. Plus 1. Okay, plus 7. Okay, here is the imaginary. This one is real part. Okay, so our magnitude G3 equal to 1 square root of real part squared plus imaginary part. 7 omega. 7 over 12 omega squared. Okay, so we have the phase angle of G3. Okay, function G3. equal to 0 minus, okay, we know this one becomes 0 like the previous function. So it's 0 minus arctangent, the imaginary, this one, imaginary. So when we make, when we find for G3 phase value, we refer the original J omega replacing J omega. So it's arctangent J, so 7 over 12 omega divided by real part, which is omega squared. Okay. After this, I will use a table. So we need to put it in the table. Okay. So this is the second step. Okay. To put it in the table, okay, we need to use a calculator, of course, but it is an advantage when we use online, then you can calculate using Excel. That's why we call Nyquist is quite tedious, because you need to make a calculation every omega. Okay. So you have to put omega here, and then magnitude G1, magnitude G2. Okay, last time in physical class, we need to use the calculator to calculate each value in the table. Okay. So the angle G1, G2, and G3. Okay, so we have 3 phase and also 3 magnitude, and we make a total of G. This is for the overall G. And then we have the total phase. Okay, so what will be the omega value here? Okay, how we know that the omega is suitable for our Nyquist plot? Okay, so omega actually is our main frequency. Okay, we take omega from here, which is 0 omega equals to 1. Okay, here. Or you can get from here. Where is it? Omega over 5. Okay, just now I already changed it into 0.2, right? So make it 0.2 for main frequency. Okay, we have 0.2 omega equals to 1. Okay, where we get omega equals to 1 divided by 0.2, then we have 5. Okay, remember previously you write this omega S over 5. Okay, S divided by 5, so it's 5 actually for the frequency, and the other frequency we get from here. Okay, we get from the 12, square root 12. Okay, square root 12 here. So actually is below the S. Or if you can remember yesterday, it's omega S over 1 value. So that value is our second omega, which is 3.5 radian per second. So this omega should be our guideline and need to be put here. Okay, let's say we have 5. Let's say we have 5 for mid omega, mid value. And we have another 3.5 here. So our other omega should be filled by our own. We have 1, 2.42, 4, 5, and 8. So this is frequency that we already know here for main frequency, okay, by using the frequency in the function in the question. Okay, so we have 2 omega here, and then the other omega will be put by our own. What else? Okay, we need to have more than 5 so that you can draw the Nyquist in proper way. Okay, so what else? How to calculate our G and the phase angle. Okay, let us use Excel. Okay. Let us use Excel. Okay, here is our Excel, and we use the same formula here. Okay, what is our G? What is our G? Okay, sorry, I cannot see from here. G1, G1. Okay, magnitude G1. Okay, here, 10/6. So it's constant value, okay, without affecting the omega. So it's constant 10 divided by 6. Okay, we make a table here. So it's G1 magnitude. G1, okay. So G1 equal to 10 divided by 6. So that one is G1. And then we calculate for G2. Okay, this is omega. Okay, let's say W. 1, 2.42, 3.5, 4, 5, and 8. Okay, now we calculate this one, all omega, all same value. Okay. Now we find for G2. For G2. So for G2, we need to copy the formula. Okay, what is the formula for G2? G2 is here, magnitude 1 divided by, okay, 1 divided by 0.2 omega times this one, and then okay, plus 1. Plus 1. Okay, what else? 1 divided by square root. 1 divide okay, 0.805. Okay, let me check the answer. Okay, I think that's correct. And then we copy this. Okay, otherwise you need to use your calculator. Okay, you need to use your calculator. So let me check. Okay, B12 follow omega, new omega. Okay, we have another G3. Okay, G3 amplitude, amplitude here. Okay, so we have omega here. Divide 12 plus 1. Okay, plus 1. Okay, this one should be in degree. Because I get in radian, right? Is it the correct function here? A tangent, up for up tangent. In range negative pi over 2. So it should times 2 divided by pi. How about tangent 2? Minus pi. 0.2. Okay, sorry. I need to make a new Excel. Okay. Anyone know how to make a arctangent? What is the function for arctangent? Written in degree. Written in degree. Written in degree, eh? Okay. This one 0.919. So it should be times 90 divided by 2, eh? Because it's pi over 2. Okay, can someone use calculator for this kind of function? Negative arctangent 0.2 times 1. So arctangent 0.2 written in degree. So what is the value? It should be negative here. Negative 17. Please someone help me to calculate using your calculator. What is the value you get here? Okay, what is the value written for G2? G2 is negative arctangent 0.2. Is it correct using your calculator? Arctangent, what is it? 0.2. Okay, using my calculator. 11.3. Correct. G2, yes, betul. Negative 11.3. Memang your calculator will return value tu Negative arctangent. Kalau guna Excel 11 tadi kan? 11. Okay, try bahagi 2 Bahagi 2 dapat 17 bahagi 2 tak dapat 11. Kan? Negatif tadi. 11 betul. 11 tadi jawapan dia betul. 11.3. Okay. Okay, cuba ada seorang boleh try pakai Excel tak? Macam mana dia punya ni? Nak masukkan 0.2 times ni betul dah kan? Cuma ni arctangent ni. Ke 1 over tangent? Apa dia punya rumus Kalau guna Excel, boleh tolong saya tak? Kalau guna tangent tu tadi Tangent tu. Too few argument. Betul. Sebelah saya tadi 8. Okay, mungkin function ni. Apa lagi function tangent? Bukan juga. Bukan juga. Tak dapat 11 tadi tu. Siapa boleh try guna Excel yang ni? Apa function dia? Satu per tangent. Dapat berapa kalau satu per tangent? 4.9. Sebab mungkin ni dalam radian. Tapi kalau dalam radian, okay, siapa lagi boleh tolong? Cuba cari sampai dapat 11.31. Sebab kalkulator dah dapat dah. Memang betul dah jawapan dia 11.